Hello, this is your special education virtual content specialist with the 8th grade lesson for May 6th. This lesson, as with all other lessons, can be found on TeachHub, and this lesson, like all other lessons, provide teachers with the title, the focus question, the learning objective, including standards and objectives, guidance for using this resource, including instructional and technology guidance, implementation guidance for the lesson, guidance for summarizing, guidance for assessment during instruction, and general methods of engaging students with disabilities and multilingual learners. 8th graders are working on Unit 8, the Pythagorean Theorem and Irrational Numbers, Day 9, Reasoning about Square Roots, Part A. How can we determine which whole numbers a square root is between? For the do now, you're going to ask students if the statement is true or false, and in order to provide students with processing time and not overwhelming them with all the problems on one slide, I divided it up to one problem per slide, and I made it a option slide so students can choose true or false, and then you can have that discussion piece after they choose. In order to further support students with disabilities for any processing or memory issues that they may have, provide sticky notes or mini whiteboards or virtual whiteboards to aid students with working memory challenges. So, square root of 5 squared is equal to 5. That statement is true. Square root of 9 squared equal to 3. It is false. 7 equal to square root of 7 squared is true. Square root of 10 squared equal to 100 is false. Square root of 16 equal to 2 squared is true. For the Explore, all the numbers were on one slide, so you might want to break it up to a few per slide. So I can do an I do, we do, you do. So for square root of 7, I'm going to say, okay, square root of 7 is between the numbers 2 and 3. I know this because 2 squared is equal to 4, and 3 squared is equal to 9. So the square root of 7 has to be between those two perfect squares. So this can be a we do, and students should get that the square root of 23 is between 4 and 5. And that their reasoning should be that 4 squared is equal to 16 and 5 squared is equal to 25, so square root of 23 has to be between those two numbers. This portion of the Explore is a you do, so you can help set it up so that students can fill in the two numbers and then explain without thinking about how to structure their answer. So the square root of 50 is between 7 and 8, because 7 squared is 49 and 8 squared is 64. So square root of 50 has to be between those two numbers. And 98 squared is between 9 and 10, because 9 squared is 81 and 10 squared is 100. So square root of 98 has to be between 9 and 10. So after they complete this slide of the Explore, you can discuss what strategy did you use to figure out the two whole numbers. So one can be, I made a list of perfect squares, then found which two numbers the number was between. Did anyone use inequality symbols when writing their answers? So some people may have said, for example, 2 is less than square root of 5, then less than 3. So once the class is satisfied between which two whole numbers those square roots lie between, ask students to think more deeply about their relationship. So one possible misconception that could be covered here is that if a number is exactly halfway between two perfect squares, then the square root of that number is also halfway between the square roots of the perfect squares. For example, students may think that square root of 26 is halfway between 4 and 6, since 26 is halfway between 16 and 36. It's close, since square root of 26 is approximately 5.099, but it's slightly larger than halfway. So this is a good opportunity to remind students of the graph they made in a previous lesson, showing the relationship between the side length and area of a square. The graph showed a non-proportional relationship, so making proportional assumptions about relative sizes will not be accurate. So here, you can have students think about that. So square root of 28 is between 5 and 6. And you want to think about which one is closer now. And so you can say it is closer to 5 than 6. So if students are using a calculator, they can see that square root of 28 is 5.2915026, so on and so forth. And so on a number line, that would be closer to 5 than it would be to 6. For the summary, students are answering how can we determine which whole numbers a square root is between. You can provide them a sentence starter so they're focused on the content of their answer rather than the structure. There is a lesson support video, so please guide students who are struggling to this resource. For additional practice, students can do F.16 and F.18 of the 8th grade IXL, estimating positive square roots, and estimate positive and negative square roots. There's also Khan Academy, approximating square roots, the Open Up practice problems, and Engage New York grade 8 module 7 problem set. Here are the resources used to create these lessons. So if you would like to further support your students in their remote learning, please feel free to utilize these resources. And if you have any questions, please contact your virtual content specialist. Thank you.